excited to talk today about monitoring. Who am I? Just a short introduction. My name is Blerim, and I work for Netways, which is a company located in Germany. A company dedicated to open source software, and as well dedicated to monitoring in general. I work there as a product manager, taking care of our partners and our integrations and all this kind of stuff. And today I want to talk about monitoring. And the first thing when I say monitoring, most people think of, monitoring kind of sucks. Whose first thought is that when I talk about monitoring? Yeah, at least somebody. So there are many reasons why monitoring sucks. I think it's the biggest problem is the way how we configure our monitoring tools, because people just don't care as much as they should, and they just configure something, and later they just are missing something that they needed, but they didn't configure it. So today my talk will be about continuous monitoring. And what I want to talk about is how you can keep your monitoring up to date. So if your infrastructure in any way changes, your monitoring software should reflect those changes. So you shouldn't have manually to configure anything, because you probably will forget about many things. The most important part is that it should happen without any human interaction. So when I say continuous, the root of the continuous part is automation. And when it comes to automation and cycles and continuous anything, be it continuous monitoring, continuous integration, continuous deployment, continuous delivery, it's every time a cycle of doing something. So every time you repeat your steps automatically. And without automation, continuous anything wouldn't be possible at all. So there are many reasons why I should automate my monitoring configurations. When people first started, they had only physical machines and just a couple of them. And configuring monitoring was annoying, but it was doable. So you could do it manually. You were annoyed by it, but it was doable without many stress. This is possible if you have just a couple of machines. If you add just 10 servers per month to your infrastructure, you can do the monitoring manually, and it's doable. The next step is if you have virtual machines. If they are all the same, you could do the manual configuration of your monitoring as well. That would be more annoying, but still you can do it. The thing about this is the more machines you add, the higher the frequency of your changes in your infrastructure is, the higher the failure rate will be when you configure anything manually. The next thing is that not all servers are the same. So when you add new servers to your infrastructure, they come in all flavors, shapes, and sizes. And this increases the failure rate of the configuration even more, because now you have to think about even more things when you configure the exact monitoring you want to know about these servers. And last but not least, what's increasing the failure rate most are users. Usually in companies there's not only one sysadmin that changes the configuration of monitoring, usually there are more than 2 or 3, and each of those sysadmins have their own thoughts how monitoring should look like. They have their own ways to configure things. Even if you have conventions and rules, something may break because your sysadmins are humans, and humans make failures. Humans forget about things. So your monitoring won't be complete at some point. So you may reach a point where you have some kind of monitoring in your infrastructure, but even basic checks for some servers are missing. And this is mostly due to human errors. So let me give you a short introduction into Izinga. Izinga is so just a quick poll, who is already using Izinga to monitor infrastructure? A couple of people. I will just give a short introduction how it works and what it does. Izinga is an open source product. It's fully open source, and it's is there to monitor your infrastructure and any application on this infrastructure. With infrastructure, I mean really anything. It doesn't have to be a virtual machine or a physical server. It can be an environmental sensor. It can be something in your IoT environment or anything. Izinga runs actively checks to check if your application or your server is available, and it receives those results. Based on these results, Izinga can decide if a user should be notified, if an action should be triggered. It saves those results in a database to have a historical overview over the past events. In the same run, when Izinga runs an active check, it collects also metrics about this thing. So let's say, for example, you're just checking if a server is available via ping. You will have the information that it is available, but you will have also the information how much time the ping took and how much packet loss you have. These metrics can then be saved in a time series database of your choice, be it Graphite, InfluxDB, OpenTXDB, or Elasticsearch. Last but not least, Izinga provides a nice overview in a dashboard where you can see all your services and how they look like and what's the state of the current services. The basics of Izinga are Izinga 2 and Izinga Web 2, where Izinga 2 is the core and Izinga Web 2 the web interface. Izinga was built from the beginning to be extensible with modules and plugins and features, as well as Izinga Web 2. So every component we provide is extensible in some way. One important part is that you can connect Izinga with many other tools. So if you have a DevOps tool stack in your environment and you have stuff like Graphite or you have Elk Stack or whatever, there's always a way to connect Izinga to it and to communicate with different tools. We decided to do that this way because we want to focus on the thing that we can do best, and this is monitoring. So we focus on how to check if everything is alright, and stuff like logging management and time series databases, we just connect to them to make sure you have the best tool stack that fits your needs. The three key aspects of Izinga are monitoring as code, scaling secure, and integrate and extend. With monitoring as code, we mean that you shouldn't just configure each object one by one, but you rather should write a configuration that looks more like code that describes the things you want to do, and the software itself will configure everything dynamically through your runtime. There's a cluster mechanism built in with it, which is SSL secured. So if you connect more than one Izinga server, you will always have a SSL secured connection. You can use Izinga also as an agent on your hosts. And integrations are a big part of the concept, how we want to run this. So these are the basics how Izinga work, but how can we automate our configuration with Izinga? I came up with the description like describe and express, because that I think that's the best way to describe how this works. And I want to create a continuous monitoring out of this concept to say I want to describe something, and everything something changes, this description should apply to every change. So let's say as a human, you will have sentences like monitor engine X on any web server, and this just should work. So this is the most simple way to express something, and every one of you may know the results of what this should do. A more complex example would be monitor MySQL on any database server that is in production, but not those located in London, because I don't care about that. This is a little bit more tricky, but still doable. And I think this is the goal. This is how we should do monitoring. We should just describe the things we want to do, and the software should just work for us and do these things. If a new server appears in our infrastructure that actually is a database server and that has MySQL installed, my monitoring should be able to recognize that. And it should run the checks automatically without me having to configure that manually, because as a human I will probably do something wrong, or I will just simply forget about anything. The same applies for notifications. So if I have a server farm and I want to say, okay, notify me about this certain things, but only during business hours. So this is a typical case, what users do when they do monitoring. Remember those phrases because I will just get back to it right now. The first step in this concept is to describe stuff. So a server typically has attributes. Other software calls them facts or whatever. But they're just attributes describing the characteristics of a certain server. For example, an attribute will be what operating system is installed on the server, what applications are running on the server, what kind of server is this, do I need on-call notifications for these servers, and many, many more things. And based on these attributes of a server, I think I can decide what should be monitored and how it should behave if something goes wrong. Technically, in the configuration format, this may look like this. This is the most simple object that can be created in a single configuration. A single configuration is based on objects. So everything you configure is an object. For example, here we have a host object. It has a check command, it has an address, it can import from templates, simple stuff. But the most interesting part about this object are the attributes right here, because they describe the characteristics of the server. These attributes, we call them custom variables because they can be anything you like them to be. We can write information about the servers in these custom variables. For example, we can say that this server is a Linux machine. This server has MySQL installed. This server is located in Moscow, and it is in a production environment. Now, this is the step I want to automate. I shouldn't have to do this manually. But if I have those attributes, I can write rules. So I can express what my monitoring server should do actually. Remember the phrase monitor any MySQL server in production and not in London? Technically, it looks like this. This is a very simple rule written in async.config, and it tells us that we should apply the service MySQL on any server. So I assign actually this rule, we call them apply rules, on any server where the MySQL attribute is set and that has the environment prod. But it should be ignored on servers that are located in London. So this is exactly this phrase just rewritten in configuration format. And the best point about this is that if you add a new host that has these attributes, this rule will apply automatically. The service checks will be generated automatically. You don't have to take care about, oh, now I need to use this check plugin, or now I need to use this users to define how we should notify and everything. Apply rules maybe, this is a very simple one. Apply rules may be even more complex than this. For example, you can add arrays and dictionaries to them, because just simple strings and booleans are not enough to describe anything. You can add, for example, dictionaries. Let's say we have here a server that has more than one virtual host configured on it. We can say that, okay, here's a virtual host called async.web2. It's reachable through the URL /async.web2. But I have also on the same server a Grafana installed, which is reachable over the port 3000. What we do here is that we just not just describe what is configured on the server, but on the same run we also configure what should be monitored, because the exact same custom variables here will be later used to actually configure the service that is run against the server. These are just the basics, and I just don't want to go too deep into the technical stuff about apply rules and host definitions. I'd like to talk more about automation, but the apply rules, these were kind of simple ones. They can have also, you can do pattern matches, so you can say, I want to monitor this one on every server that starts with SRV dash or something, so you can use regex patterns to match names or definitions or anything. You can even go further and use conditions and decide during runtime how the service should behave. For example, you want to say that during the backup time, this server can have a load of 20 and I don't care. But outside of this backup time period, if the load is higher than 5, please notify me, so you can create conditions about it. You can loop over everything, so you can dynamically create objects with just defining how the loop looks like. And you can even use custom functions to describe your stuff. So I think the most sophisticated thing I saw is someone during runtime parsing metrics, and based on these metrics from multiple hosts and multiple servers, setting the state of another service and notifying about it. You can with custom functions you can get each and every attribute of every object during runtime and decide what to do in certain cases. When it comes to automation, I like to split the automation part into 3 parts. I call them stages of automation because I think that users that do a lot of monitoring usually go through these stages when they're using Izinga. And the most simple stage, I think, is just to use configuration management. With configuration management, you can automate almost anything, and so you can do with monitoring. If that is not enough, you can use a module called the director, which has the ability to automate almost anything. And if this isn't even enough for your special requirements, you can use the REST API to just do anything you want to do. Configuration management is something that is pretty widespread currently, and everybody uses it, and everybody should use it. And you could automate your monitoring with using configuration management. We have pretty great Puppet modules that are approved. We have a cookbook that is the partner program of Chef, Ansible stuff, and also SaltStack. But if you're using configuration management, at some point, in combination with monitoring, you may reach some limits, because your monitoring software sometimes just needs additional information than those that the configuration management can provide you. Let's say, for example, your Puppet may not know anything about your Active Directory users, or your Chef doesn't know what is configured in your LDAP. But you need those information to decide what user should be notified in which case. But on the other side, these tools can provide you very great information about characteristics of a server. Configuration management is a very strong basis, but in certain cases you just sometimes need more than this. And that's where we came up with the director. The director is a web module, so it's a module for Izinga Web 2, which is built to allow you to configure anything through a web interface. So this is the configuration part is for users that don't want to use configuration files. that want to give access to other users to just certain parts of the configurations. For example, if you want to give your users access to change thresholds in your monitoring, but not change any definition. But it was also built with automation to allow you to create automation processes. An automation process in the director looks like this. So the first step is that you can import information from multiple data sources. So, for example, you can import information from a MySQL database or a Postgres database, where you may have information from your CMDB or from any other tool that you someday have written and uses a database. You can just import this information. You can use also your users that you have configured in your Active Directory and import these information into your Izinga configuration to use this later and to react on this information. So there are some general import mechanisms and some that are specialized to certain software like VMware or AWS, so you can just continuously import information about your VMware cluster, or you can also import information from your configuration management like Puppet. So there are plenty of possibilities, and the best thing about this is that it's extensible. Even if these import mechanisms don't meet your requirements, it's pretty easy to add your custom one. If you have something that has an API, you can just create an import mechanism for it. The next step in the director's automation cycle is the synchronization. When you import this information, you need to tell the director how to map them to Izinga attributes. For example, the host name on the CMDB database is the object name in Izinga. The address here is the address there, and this kind of things. Afterwards, you can merge this information with other information that are already configured. For example, if you're importing a new data source and want to merge it with existing configuration, you can configure how this should be done, if the old one should be purged, if the old one should be merged with a new one, if existing objects should be replaced and anything. You can modify the attributes, for example, write everything lowercase, uppercase, whatever. You can decide what to do with duplicates and all this kind of stuff. So in reality, you don't have just this one, so you can have just one import mechanism, but in reality there are usually more than one import source. So for example, you can import your hosts from your CMDB, where you every time write them down. You can import your users from your Active Directory, and you can import some facts from Puppet. The director will use every attribute and try to merge this information to build one Izinga configuration out of it. And you have many opportunities to decide how this should be done. This is kind of a real-world example. This is what it's currently done with the director. And afterwards, if the director was able to create this configuration, it can deploy it to your server. Even if you have multiple Izinga servers, the director can decide how to deploy these configurations. Rather than just talking about it, I'd like to demonstrate how this in reality can work. Just give me a sec. So this is a default Izinga web interface. You can see hosts and services, you can acknowledge something, you can set downtimes, send notifications, just have an overview of everything what is configured. The director has the ability to automate stuff. So the first one is import sources. Where do I want to receive my information from? For demonstration, I have prepared a database that is As simple as that. So there's a hosts table, and it just has 6 entries of some sample hosts. So there's a host located in Moscow, London, Berlin with some attributes. Let's imagine that this is your CMDB with many more information than this test case. I can add an import and just give it a name like CMDB. The source type, the built-in source types are SQL, LDAP, and Core API. I will use the SQL source type. And I will define what's my key column name. So this is the unique key in this table. I will select as a resource name. The resource name defines on which server to connect, which credentials to use, which database to use. I've created that before the talk. And then I can just write my SQL query to get my information. The easiest one will be just select everything from the hosts table. And yeah, that's it. The import hasn't run yet, so I can check for changes, and it will tell me, okay, there are changes. I detected that there is something in this database that you haven't imported yet. I can have a preview of it. So these are the information that I had in my table. The 6 servers I hadn't done before in my configuration. It recognized it. Yeah, now I can just work with it. After the preview, after I'm sure that my query is working as it should, I can just trigger the import. It will do its thing and tells me, oh, all right, I imported this information successfully. From this on, I can work with this information. The second part is you have to synchronize this information with existing configuration. So you have to tell the director which column is what Izinga attribute, which is actually pretty easy because it's everything in the web interface. So I'll call it CMDB sync. I define that this table is used to import hosts, so I can also import services, groups, users, whatever. But in this case, I want to import hosts. If something is already inside there, I want to replace it, but I want to purge anything. Now the tool is telling me that there are no sync properties, so I have created a sync rule, but it doesn't know how to behave when it tries to synchronize. And therefore I will just add some properties, some mapping. The first thing is that I will tell the director for every host to use a default template with just some default settings. Afterwards, I will tell the director that the Izinga attribute object name, so the name of the object comes from the column host name. The next thing is that I tell the director that the object address should be mapped to the column name IP. And I talked about custom variables. I can map them as well. I can tell the director that I want a custom variable that describes the attribute, which is called location. And I want to map this with a column location. And the last one, another custom variable called environment, where I say, okay, this custom variable should be filled with the value of the environment column. So this is our mapping. This is what happens when I hit the sync button. The director will take this information out of the MySQL table, map it to Izinga 2 configuration, and merge it with existing configurations. So I can just try it out and check for changes. We can see here that there are 6 changes pending because there was nothing, so I'm syncing from scratch and just trigger the sync. Now it tells me the sync has run at this time, it was successful, and it has created 6 objects. And here I see that there are 6 host objects pending for deployment. So this is not deployed yet. I just have it imported and synced, and from this step on I can now decide when and how I want to deploy it. The activity log tells me I have 6 new servers, and I just can hit the button to deploy these changes. The director will validate the configuration. It will use the Izinga API to push a config package, so not every change is one API call, but rather it's one API call with a whole bunch of configuration in it. And afterwards, if everything is successful, I can see that the configuration has been deployed and that the reload has happened automatically, and from now on I should see those hosts in my monitoring configuration. So here I have 6 new hosts. They have the name I have provided in the database. So they have some checks applied. They have the custom variables environment and location also mapped from the database. And if I change anything in the database, the import and sync mechanism will change it in my monitoring configuration as well. But this is not automated yet. So the last thing I would have to do to automate this stuff is to create jobs to decide how often and at what time I want to do certain things. So for example, I could say that I want to import every hour or every minute, but I want to deploy the changes only during business days, because then I can have an eye on it. The director can do even more things. You have a full audit log of everything that is happening. Every configuration change that happens gets its own configuration version. So when you see that your import mechanism or your automation does something wrong, and you certainly have somehow deleted everything in your monitoring configuration or broke anything, you can just use an older version and just roll back by hitting the deploy button on an older version. You can overview everything, and you can use a diff tool to see exactly what would be changed if you deploy this. The director uses the Izinga 2 API, but the Izinga 2 API is not only built for highly sophisticated tools, it's rather built to be used by everyone. The Izinga 2 API is built because we thought that every business is different, and everyone wants to connect with something different, and everyone wants to integrate with anything. And it should be able to just use hooks to do something in your monitoring, be it set a state of a service passively without the monitoring doing anything, or create objects or whatever. The Izinga 2 API is RESTful and provides authentication mechanisms that let you authenticate the users either via basic auth or with certificates. You can set permissions, so users are only allowed to do certain things via the API. Basically, you can do anything with the API you can do with a configuration. So create, modify, delete objects. You can inspect objects for debugging purposes. You can send results passively, so if you have something in your infrastructure that runs the checks by themselves, you can pass those results to Izinga, and you will have them in the web interface as well. You can run actions from remote. For example, if you want to set a downtime when your backup starts, you can just call the API and tell it to do so. And you can use you can stream events to receive information as they happen in the Izinga monitoring tool. And I would like to show here as well how this works. So for demonstration purposes, I've set up a mini queue. So it's basically a Basically, it's a Kubernetes cluster minified, so it's just one virtual machine running on my laptop where Kubernetes is installed and where I can just use anything I would do in a real world Kubernetes setup as well. It's just for demonstration purposes. And this Kubernetes setup I've just written this for demonstration just to show what the API is capable of. This Kubernetes runs a deployment called Izinga operator. This Izinga operator will react on every event that is happening within the Kubernetes cluster. So for example, if pods are created, deployments are created or whatever, it will react on those events and use the events to trigger something in the Izinga monitoring. So let's say, for example, I just want to deploy a simple Nginx web server. This is just a simple web server without anything in it, just to show how this can work. I will see that it has been deployed. There's one pod. It is available and everything is fine. This could be my web application, for example. What the operator does, it creates the services for this. So here I can see that there's a monitoring objects here, and it has been created automatically when I hit the create button. So let's say if I delete the deployment again, so it's gone, and in the monitoring, the service is also gone, so there's no service anymore. This goes even further. I'll just create it again, so we will see here that it appears immediately. And I just decided that this web application should be scaled to 10 more replicas. So here I decide, okay, scale this deployment to 10, from 1 to 10, so 9 more. The Izinga operator will react on the events, and immediately I will have the exact same amount of web applications monitored by my Izinga. This works also the other way around. If I decide to scale down to only 3, I can do that by just using Kubernetes as usual, and it will react on these events. It will take some time because Kubernetes doesn't actually delete them when it tells them it deletes them. It takes some time, but when they are gone, they will also disappear in the monitoring configuration. All right, as a conclusion, there are these concepts of automating your monitoring configuration with Izinga. You should describe and express what you want to do. You can use configuration management tools, you can use the director, or you can use the API to customly build what you need, or you can use every 3 of them to build whatever fits your needs. I think it's a very complex topic, and with big infrastructures it may take some time, so it's nothing that you can build in 2 hours. So probably you should start slow, get comfortable with the configuration format, get comfortable with the tools, how the director works, just play around and see what it can do for you. Just experiment with everything that is involved in your automatism mechanism. And yeah, don't be scared of using the API. It's really built for end users, and it's built to be as easy as possible, and it's built to be used by anyone. So don't be scared of using APIs. Thank you very much for attending my talk. If you have any questions, I will answer them. I will try to, at least. As an open source project, we are always rely on your feedback, and as an open source project, we also are always searching for new partners. So if you have feedback, if you want to become a partner, get to me. Thank you very much.
So any questions?
Hi, thanks. Is this just some kind of inventory system or registry? Because I'm monitoring my service, okay, in Nginx, and what can I do with it? I can just check this, it's not live, and
So basically you can do whatever you want. What typically for, let's say as an example, your Nginx web server, typical check would be to check if it's alive. If the website returns the content you expect it to return, if it is returning the content in a certain amount of time, and you can decide based on these things what you want to do. You can save these data into databases and have nice graphs out of it, and you can you could notify your users. So the idea is that you check anything in your infrastructure that you cannot check manually, and get notified if something is different than that you expect it to be.
so it means that I install your agent on the servers, right?
Yeah.
Then I describe some logic to check
Yeah.
something,
Yeah.
and your agent deploy this particular checks.
Yeah, so it depends on what you want to check. If your service that you want to check is available through remote, you don't need an agent. For example, for web servers, you can access them from remote. You wouldn't need an agent. But if you want to run checks on the servers where you need local information like disk or CPU or something, you would need an agent.
Okay, thanks.
Yeah, thank you. Maybe just pass the microphone.
Thanks. So, I wanted to ask, is Izinga only for infrastructure monitoring, or can it also be used for some application level monitoring, like grab through some application logs or go to some event table in their SQL database to check for unprocessed things and so on?
Yeah, so Izinga usually uses plugins to run its checks. Plugins can be written in any programming language. They are not new. We rely on the good old monitoring plugins because there are so many out there. So for almost anything you can find a monitoring plugin, which is basically just a script written in something that gets information about something, interprets them, and returns a result if it's critical warning or if it's okay. You can also connect Izinga with other tools. So if you say you want to correlate your monitoring data with your logging management and see it in one overview, you can connect it to the Elastic Stack, where you save your data in Elasticsearch with Graylog or with Elastic, and you can combine these data saved in Elasticsearch and view them in one nice overview to just correlate and see, okay, this user has logged in, I see that in my logging information, and at the same time, this service returned a problem state.
Right, thanks.
Thank you. All right. Thank you very much.